Been hearing from a lot of you about the intricacies of construction here in New York City, and one form in particular keeps coming up, doesn't it? The TR2.
It really does. It's pretty central. You can't really talk concrete in NYC without, getting into the TR2.
Absolutely.
Yeah.
So today, let's really unpack this. What exactly is this TR2 form? And, why should people care? Whether you're the client footing the bill or the contractor actually doing the work, why does it matter right from the start?
That's the key question, isn't it? Fundamentally, the TR2 is, well, it's a technical report form. It comes straight from the NYC Department of Buildings, the DOB.
Okay, DOB official form.
Right. And it's very specific to our 5 boroughs. It acts as this really critical record for all the concrete sampling and testing that happens on a job.
Gotcha. So purely an NYC thing.
Exactly. You can think of it like this. It's a crucial piece of paperwork, and it's active right from that pre-pour planning stage, after the permits are issued, and it stays active all the way through to the final sign-offs.
So it follows the whole concrete process.
Pretty much. It's all about making sure the quality is there and, well, ultimately ensuring the safety of the concrete work.
Got it. Quality and safety. So it's not just some form you fill out and forget. It's like a living document during the job.
Yeah.
Now, for this deep dive, we're basing this on some official sources, yeah. Like that concrete safety manager checklist from nyc.gov.
Yeah, that's one source. It gives a really good overview. And we've also looked at some material that details the specific step-by-step process for the TR2.
Okay, so our mission today is pretty clear. Make sense of this TR2. Who are the key players involved? What are the critical steps, especially for clients and contractors who have to deal with this day to day?
Precisely. So let's start right at the beginning. What is the TR2? At its core, like I said, it's the DOB's technical report, specifically for concrete sampling and testing.
Technical report. Sounds pretty formal. What makes it, technical?
Well, for one thing, it has to be typewritten, no handwriting allowed, which, enforces a certain standard.
Okay, no scribbles.
Right. And it's got specific spots for all the key data about the pour, the testing. It's the city's formal way of tracking this really critical part of construction.
Makes sense. The official record.
Yeah.
So what kind of information actually ends up on this form? What are we talking about?
Oh, it's pretty comprehensive. There's a whole test report section. That's where you'll find things like the concrete strength, measured in PSI, pounds per square inch.
Right, the PSI.
And it shows the age when it was tested. Now, this is typically at 28 days, but sometimes you'll see 56-day tests too, just to check that longer-term strength gain against the specs.
Okay, 28 or 56 days.
Yeah, and importantly, those 7-day break results, they're useful for the team to see early trends, but they don't go on the official TR2 form itself. Only the 28 or 56-day results count for the final report.
Ah, okay, that's a key distinction. 7 days informational, 2856 is official for the TR2.
Exactly. And the form also clearly states the designed concrete strength. So you can see right there, did it hit the target or not?
Got it. A clear benchmark right on the page. What other details are captured?
Well, then you get into the real nitty-gritty of the sampling itself, the exact date the samples were taken. Unique ID numbers for every single test cylinder, those little concrete pucks they make on site.
Right, the ones they crush later in the lab.
Those are the ones. The report also details all the field test results. These are tests done on the fresh concrete during the pour.
Like what kind of tests?
Things like the slump, which basically tells you about the concrete's workability. How easily it flows. Is it too stiff, too wet?
Right, it's consistency.
Precisely. Then there's the air content. That's super important for durability, especially with our freeze-thaw cycles here.
Yeah, makes sense.
You also record the concrete's temperature when it's poured, its unit weight, even the specific location in the building where that sample came from, and the total amount, the volume of concrete poured that day.
Wow, that is a lot of data for every single pour. Sounds like they're tracking pretty much everything.
They really are trying to. And of course, maybe the most critical part is the section for the actual breaking strength results, the PSI that those cylinders achieved when the lab tested them at 28 or 56 days.
Okay, so the proof is in the pudding or the cylinder break, and it goes right there on the form. Now, who actually has to sign this thing? Whose necks are on the line, so to speak?
Well, there are several key signatures. Each one represents a different layer of responsibility of verification. First, the testing lab director. They have to certify that all the testing work was done accurately, following all the rules and standards.
Okay, the lab takes responsibility for the testing accuracy. Who else?
Then the design applicant, that's usually the professional engineer, the PE, or the registered architect, the RA, they also sign off.
What are they signing off on?
They're confirming that the test results either meet the original design plans and specs, or, and this is important, they have to clearly note any exceptions or problems found.
Ah, so if something's not quite right, it has to be formally stated right there on the TR2, no hiding it.
Exactly. Transparency is built in, or at least it's supposed to be. And there's one more really important signature: the concrete producer.
The company that actually mixed and delivered the concrete, they signed the testing report.
Yep. They signed to confirm that the concrete they actually delivered to the site matched the approved mix design for that project.
Huh, interesting. So even the supplier is formally tied into this final testing report. It really does seem to loop everyone in.
It really does. It acts as this central, kind of legally binding document. It holds everyone accountable for their specific piece of the concrete puzzle: the lab, the designer, the supplier.
Okay, that makes the document itself much clearer. Now let's walk through the actual process. How does this whole TR2 procedure even kick off, before the first concrete truck even rolls onto the site?
Right, this sequence matters. Actually, some key signatures happen very early on. Before the plans are even fully approved by the DOB, the applicant of record, the PE or RA, signs the TR2. And the building owner signs it then too.
Okay, owner and designer sign early. Why then?
It seems to be about locking in the agreement on who will be responsible for the design aspects relevant to the TR2 testing criteria from the owner's side too. Then, before the actual construction permit is issued, the chosen licensed concrete testing laboratory adds their signature.
So the lab signs before the permit.
Yes, this initial signing sequence basically gets everyone on the same page about which specific licensed lab is going to handle the testing for this job right from the very beginning. It locks in that relationship formally.
Okay, so those first signatures are all about establishing the key players and responsibilities, especially locking in the testing lab before work starts. What's the next practical thing that needs to happen? Getting the form itself.
Exactly. The client, or more often the contractor working for them, needs to obtain the official TR2 form. Nowadays, that's usually done electronically. You typically get it through the DOB's online system, DOB NOW.
Okay, so download it or access it online. Then what's the absolute must-do step before any concrete actually gets poured?
This is critical. Contacting that chosen lab, the one everyone agreed on and who signed the form, you have to give them advance notice about when you're planning to pour the concrete.
Can't just call them the morning of, right?
Definitely not. The standard recommendation, really the requirement, is to give them at least 24 to 48 hours notice before the scheduled pour.
Okay, a day or two heads up. Why is that so important?
Well, they need that lead time. They have to schedule a certified technician, make sure someone qualified is available and can actually get to your site during the pour. It's all about logistics for them.
Right, makes perfect sense. They need to plan their resources. Okay, so planning and good communication with the lab are key before the pour. Now let's jump to the day itself. Concrete trucks are lined up. What's the TR2 process look like then on the ground?
Okay, so pour day. The testing lab sends out one of their technicians to the job site. And this person, they must have an ACI Field Grade 1 certification.
ACI, American Concrete Institute.
That's the one. That certification basically means they're trained and qualified to do the required field tests on the fresh concrete properly. And they have to be there while the concrete is being placed.
Okay, so a certified tech on site during the pour. What are they actually doing?
Their main job during the pour is to conduct those field tests we mentioned earlier. They'll measure the air content of the fresh mix, do slump tests to check the workability, take the concrete's temperature, and figure out its unit weight. These are all immediate checks on the concrete quality as it's coming out of the truck.
So making sure what's being delivered is okay right then and there.
Pretty much, yeah. Ensuring it meets those initial specs. And crucially, this is also when the technician makes those standardized concrete cylinder samples, the ones that get tested later for strength.
Right, those all-important cylinders. How are they handled? Is there a special way to make them?
Oh, absolutely. They have to be made very carefully, following really specific ASTM procedures. It's critical that this is done correctly by someone who's trained and certified. Why? Because the accuracy of all the later strength tests depends entirely on how well these samples were made and initially cured.
Garbage in, garbage out, basically. If the sample isn't made right, the test result doesn't mean much.
You got it. So proper technique there is vital.
Okay, so they make these cylinders. What happens to them right after? Do they go straight to the lab?
Not usually, no.
Yeah.
Typically, they're actually left right there on the construction site for the first, say, 24 to 48 hours.
On site. Why?
For initial curing. The contractor is usually responsible for providing something called a curing box. It's basically an insulated box designed to keep the temperature stable for these brand new samples.
Like a little incubator.
Yeah, kind of like that.
Ah.
This initial curing period on site in a stable environment is really important for the concrete to start hardening correctly.
Okay, so they sit tight for a day or two, then what?
Then, the lab technician usually comes back to the site the next day to pick up those cylinders. And getting them promptly is important too, so they can be moved into the controlled environment back at the lab quickly.
Okay, so careful handling continues. They get picked up, transported to the lab. What happens next? What's the lab's role in the TR2 process once they have the cylinders?
Right. So once they're back at the lab, the first thing is they carefully take the molds off the cylinders. That's called stripping.
Okay.
After they're stripped, the cylinders go into a very controlled curing environment. This is usually either a special room with really high humidity, like a fog room, or it might be a water tank filled with lime-saturated water. And critically, both are kept at a very specific, regulated temperature.
To make sure they all cure the same way for accurate testing later.
Exactly. It ensures consistent strength development. It allows the concrete to cure under these ideal conditions, so the strength tests later will be a true reflection of the concrete's potential.
Makes sense. How long do they stay in there?
They stay in that controlled curing environment for the whole period leading up to the tests. So primarily that's 28 days. But if 56-day tests are required for that specific project or mix design, they'll keep a set curing for that long too.
And while they're curing, the lab is just watching them.
Basically, yeah. Maintaining the environment, making sure temperatures are right. Then, at the specified age, 28 days, and maybe 56 days, the lab techs take them out and perform the strength tests.
The breaking part.
Yep, the breaking part. They put the cylinders in a machine that applies pressure steadily until they break or crush. They record the maximum force it took, and that's used to calculate the compressive strength in PSI. And the lab generates its own internal reports documenting all these breaks.
Okay, internal reports first. Now, you mentioned the TR3 before. Can you just quickly remind us how that fits in? It's different from the TR2 lab, right?
Absolutely. Good question. Yeah, it's crucial to remember the TR2 and TR3 are separate things done by separate labs. The TR3 is a report from a different, totally unaffiliated lab, and what they do is test the proposed concrete mix design before any concrete is even ordered.
So the TR3 is like the recipe check.
Exactly. The TR3 essentially says, okay, this recipe should work. It should give you the strength and properties you need. It's a pre-approval of the mix design itself.
Got it. So if the TR3 lab approves the recipe, what does the TR2 lab, the one doing the site testing and cylinder breaks, have to do with the TR3?
Good question. The TR2 lab's responsibility regarding the TR3 is basically verification. They need to verify that the concrete that actually shows up on site, the stuff coming out of the trucks, that it actually matches the approved mix design that's documented on that TR3 report.
Okay. So the TR2 lab is checking the delivery ticket against the approved recipe from the TR3.
Precisely. They'll look at the delivery tickets, check the materials, listed the cement type, aggregates, any admixtures, and make sure it all lines up with what was approved on the TR3. It's another check in the system.
I see. So the field inspector might notice something looks off, but the TR2 lab formally verifies the delivered mix against the approved TR3.
That's generally how it works, yeah. It connects the design approval to the actual material used.
Okay, TR3 equals recipe approval. TR2 lab checks delivery against recipe and does the actual strength tests. Now, when do those final PSI results from the lab actually get put onto the official TR2 form? And when does that whole thing get submitted?
Right. So those PSI results from the lab's 28-day breaks and the 56-day ones, if they did them, they get formally entered onto the TR2 form by the lab. But the TR2 usually isn't submitted after every single pour.
No, that would be a lot of paperwork.
It would. Instead, it's typically compiled for the whole project, or at least for major phases of the concrete work. It gets put together towards the end, after all the pouring for that phase or project is done, and the engineer is signed off on the concrete work in general. It serves as the complete record for that chunk of work.
Okay, so it's more like a final summary report for the concrete testing for a project or phase. What are the very last steps then to finalize it and get it submitted to the DOB?
The final steps are all about getting those last crucial signatures in the right order. After the lab has finished all the testing and the results are on the form, the testing lab director signs off again, certifying the final results.
Okay, lab director first on the final form.
Then the concrete producer adds their signature, confirming again that the mix delivered was per the approved design associated with these results.
Supplier signs next.
And finally, the applicant of record, the PE or RA, gives their final signature. They're basically saying, yes, I've reviewed these results, they align with the project requirements or exceptions are noted, and this concrete work documented here is acceptable.
Engineer or architect signs last. Okay, that sequence makes sense.
Yeah, it ensures everyone who needs to has reviewed and formally acknowledged the final testing outcomes. Once all those signatures are on there, lab, producer, applicant, the fully signed TR2 form is submitted to the Department of Buildings. That closes the loop on the documentation for the concrete work.
Wow, it really does sound like a very structured, very controlled process with all those sign-offs. Now, we talked about the certified techs doing the field work. What about inside the lab itself? How do they ensure quality? It can't just be one person running tests.
Oh, absolutely not. Any reputable concrete testing lab has multiple layers of quality control. You've got the certified technicians doing the hands-on testing, sure, but then there's oversight. You usually have quality control managers, maybe quality assurance people, reviewing procedures and reports. Often there's a technical director who oversees the whole operation, the really complex stuff. They do regular internal audits. They're constantly checking and calibrating their equipment. It's huge.
Calibration, right. You've got to trust the machines.
Exactly. And they make sure everyone is strictly following the relevant industry standards, like the ASTM standards we mentioned. It's a pretty comprehensive system designed to make sure the results they produce are accurate and reliable.
Okay, so there's a whole system behind the scenes at the lab, too. Good to know. Now, thinking about our listeners again, the clients paying for the work, the contractors managing it, what are the absolute key things they need to take away from all this? What should they focus on to make sure this TR2 process goes smoothly for them?
Yeah, good question. From their angle, I'd say there are a few really key takeaways. First, just understand that this TR2 process exists, know what it is, and be clear on who's supposed to do what and when.
Know the players and the playbook.
Exactly. Second, be proactive about getting those testing reports from the lab, the LEP reports. Don't just wait until the end of the job to find out if the 28-day strengths were okay. Ask to see them as they become available.
Why is seeing them early so important?
Because it lets you catch potential problems early. If the 7-day breaks look low, or the first set of 28 days comes back under strength, you can react much faster, figure out what's going on, maybe adjust things for future pours, instead of finding out months later when it's much harder and more expensive to fix.
Right. Proactive problem solving. Makes total sense. What else?
Third, pay attention to that on-site curing box for the samples. Make sure it's being handled properly, kept at the right temperature. That initial curing is just so critical for getting accurate results later. Don't let the cylinders freeze overnight or bake in the sun.
Okay, protect the samples on site. Good tip.
And finally, just hammering this home again, remember that 24 to 48 hour notification window for the testing lab before you pour. Don't leave it to the last minute. Plan ahead, communicate clearly with the lab. It avoids delays and keeps things running smoothly.
Solid practical advice there for anyone dealing with concrete in the city. So wrapping this all up, it's really clear the TR2 form is, well, it's way more than just another piece of paper in the construction shuffle.
Oh, absolutely. You could say it's really the foundation of concrete quality assurance here in NYC. It forces accountability across the board. The lab, the design team, the owner, the concrete supplier, everyone has a role. Everyone signs off.
Yeah, and it connects everything, doesn't it?
Yeah.
The field work, the lab tests, back to the original design through that TR3 check. It's like this interconnected system.
It really is. So for clients, for contractors, really understanding their part in that system, knowing who signs what and when it seems absolutely essential. It keeps projects moving, ensures you're compliant, avoids potential headaches.
Couldn't agree more. Knowing the process can probably save a lot of time and trouble down the road. It really highlights just how complex it is to ensure the quality of something as, well, as fundamental as concrete in a city like New York. Thinking about all these layers you've described. The separate TR3 check for the mix design before you start. The on-site field tests during the pour, the independent TR2 lab doing the strength tests later. All those different signatures at different stages. It's quite a setup.
It really is. And it kind of makes you wonder, doesn't it? Considering just how comprehensive and multi-layered this whole system is, how effective is it really in truly ensuring safety and quality on every single pore, especially in a city as huge and fast-paced as New York?
That's a deep question.
Yeah, I mean, what are the real strengths of this system in practice? And what are the potential challenges, or maybe even loopholes, in maintaining such tight standards at such a massive scale? It's definitely something worth thinking about as you navigate your own projects here.
That is a really thought-provoking point to end on. It makes you appreciate the intent, the structure, but also consider the real-world application and perhaps its limits. Maybe we could explore the practical effectiveness, the potential pain points in a future deep dive.
I think that would be fascinating. But for today, this has been a great breakdown of the TR2 process itself. Thanks so much for walking us through all of that detail.
My pleasure. It's such a core part of building in New York City, and hopefully this deep dive sheds some useful light on it for everyone involved.